Hello friends, thanks for watching Edupedia word videos. Today in this video we'll be having some questions on polynomials. The first question says if a, a minus b and a plus b are the zeros of polynomial x cube minus 3 x square plus x plus 1, find the value a and b. Friends, let this polynomial be px. If px has these three terms as the zeros, then by factor theorem x minus a is a factor of px. Similarly, x minus a minus b is another factor of px, and x minus a plus b is another. Therefore, if these terms are individual factor of px, then their product, that is this product is also a factor of px. Therefore, by factor theorem we can write px equal to k into this term, that is x cube minus 3x square plus x plus 1 equals k x minus a into this product. Will be decomposing these two terms and get the product decomposed as x square minus a minus b into x minus a plus b into x. These two terms, when producted, both have minus sign, give the resultant a positive sign. Thus, we have x square minus, combining these two terms, a minus b plus a plus b into x plus, friends, this is the identity which we have studied in the 9th standard. A minus b into a plus b equals a square minus b square. On further simplification, this term becomes minus 2ax. Thus, decomposing these two terms, we get x cube minus 2ax square plus a square minus b square into x. Multiplying this minus a with this term, we get minus ax square plus 2a square x. When minus a is multiplied by minus 2ax, we get plus 2a square x plus minus of a cube plus a b square. Thus, we get k into x cube these two are square terms, we can join these as minus 3a x square plus k from the outside, and the x terms as a square minus b square plus 2a square, which gives us 3a square minus b square into k from the outside, and the constant term as ab square minus a cube into k. Now comparing the cube terms, we easily conclude that k is nothing but 1. Therefore, we can substitute k in this whole equation as 1 into 3. This again get cancelled because 1 into something is the similar term, and this also get cancelled. Comparing the terms having degree 2 or x square, we have minus of 3 equals minus 3a, implies that a equals 1. Comparing the terms having x, we get 1 equals 3a square minus b square. Now a is 1, which implies 1 equals 3 minus b square, which again implies b square. We bring b square to the left hand side and get 3 minus 1 is equal to 2, implies that b is equal to under root of 2, positive and negative. Friends, whenever we have this kind of term like b square or x square equal to some other variable, say a, then on having under root we take two signs of the right hand side, because negative of something and squaring it gives the similar term as the positive of the same thing and squaring it. Thus both the values will give the square as x square. Now on if this particular constant term also fulfills the value of a and b and satisfy the equation, then the value of a and b obtained by us will be true. Let us check this. On comparing the constant term, we get RHS equal to ab square minus a cube. A is 1 and b square is 2. 2 minus 1 equals 1, which is LHS. Therefore, value of a and b are a equal to 1 and b equal to plus minus under root 2. Let us have another question. Find a cubic polynomial if sum of zeros equal to 2, sum of product of zeros taken 2 at a time is equal to minus of 7, and product of zeros, all the zeros, equals minus of 14. Friends, let the cubic polynomial be p of x equal to ax cube 3 because it's a cubic polynomial having degree 3 plus bx square plus cx plus d. Now let zeros be alpha, beta, gamma. Sum of zeros equal to 2. Now in the video of relationship between zeros and coefficients, we have derived that for a cubic polynomial, sum of zeros equal to minus of b by a implies that minus b by a equals to 2. Again, sum of zeros taken 2 at a time means alpha beta plus beta gamma plus gamma alpha equals minus 7. This we have derived equal to c by a. Thus, c by a equals minus 7. Similarly, product, that is alpha into beta into gamma, is given as minus 14, which was derived as minus d over a, implies that minus d by a equals minus 14. From this part, we get b equals minus of 2a, taking the negative from left hand side to the right hand side. Here c equals minus 7a, and here d equals 14a. Thus, if this is the first equation, we can write as px equal to a into x cube plus b is given as minus 2a, therefore minus 2x square. This a has been taken common outside. Similarly, c equals minus 7a, a taking common. Similarly, d is 14a. Thus, ax cube minus 2x square minus 7x plus 14. Friends, this is a general polynomial. For different values of a, we can have different cubic polynomials. Say if a equals 1, the polynomial becomes x cube minus 2x square minus 7x plus 14. If a equals 2, we can have another polynomial. The question says, what must be subtracted from px equals x4 plus 2x cube minus 13x square minus 11x plus 10, so that resulting polynomial is divisible by u of x equal to x square minus 4x plus 3 and degree of polynomial subtracted must be less than degree of ux. Friends, to solve such a question, first of all, the basic model we use will be to divide this polynomial by ux, the given polynomial. That is, we can write px equal to ux into some quotient plus remainder. Now, if we have some remainder and we subtract this remainder from the whole of the px, then ultimately px minus rx will become ux into qx plus 0. That is completely divisible by ux, since remainder will become 0. So we have to find rx such that the resultant px will be divisible by ux. Let us solve this problem. We are given px as x4 plus 2x cube minus 13x square minus 11x plus 10, and ux as x square minus 4x plus 3. Both the polynomials are arranged. Now, first term of the dividend is x4, the highest degree term of the divisor is x square. On dividing the two terms, we get, which is nothing, x square. Multiply x square by this whole divisor, we get x square into x square minus 4x plus 3, which gives us x4 minus 4x cube and plus 3x square. On subtracting, we get 0 over here, and 2 minus of 4x cube, which gives us 2 minus of 4, that is 6. And now minus 13 minus plus of 3, which gives us minus of 16. This term as it is and 10 as it is. Now again divide 6x cube by x square, that is the highest degree term of the new dividend, by the highest degree term. We get 6x. Multiply 6x by divisor. 6x is the new term or the second term of the quotient. Multiplying 6x by x square minus 4x plus 3, we get 6x cube minus 24x square plus 18x. 6x cube minus 24x square plus 18x. On subtracting, we get 6x cube minus 6x cube equal to 0x cube and minus 16 and plus of 24, because minus into minus is plus. We get 8 plus of 8, and the terms having x and coefficients will bear minus 11 minus 18, which gives us negative of 29x. Now divide the highest degree term of the new new dividend with the highest degree term of the divisor. We get 8, which is the next term of the quotient. Multiply 8 by the divisor, we get 8x square minus 4x plus 3, which gives us 8x square minus 32x plus 24. Subtract, and we get 8x square minus 8x square, thus get cancelled, and minus 29x minus of 32x, which gives us minus 29 plus 32, which gives 3x, and 10 minus 24, which gives us negative of 14. Thus px, that is x raised to power 4 plus 2x cube minus 13x square minus 11x plus 10 can be expressed as quotient into divisor, that is x square plus 6x plus 8 into divisor x square minus 4x plus 3 plus remainder, which is 3x minus 14. Now if this remainder is bring to left hand side, we get px minus 3x minus 14 equals a product plus 0. Thus px, that is x raised to power 4 plus 2x cube minus 13x square minus 11x plus 10 can be expressed as quotient into divisor, that is x square plus 6x plus 8 into divisor x square minus 4x plus 3 plus remainder, which is 3x minus 14. Now if this remainder is bring to left hand side, we get px minus 3x minus 14 equals a product plus 0. Thus if we have remainder 0, then we can say that this px minus this remainder is totally divisible by x square minus 4x plus 3. Thus the term or the polynomial to be subtracted is 3x minus 14. Clearly the polynomial 3x minus 14 has degree 1, which is less than the degree of the divisor ux, which is 2. A question says, if on dividing a polynomial px equals 2x cube plus 4x square plus 7x plus 9 by a polynomial gx equals an unknown term, we have quotient as 2x and remainder as 9 minus 5x. Find the value of divisor gx. Friends, we have to find gx, the divisor. We will be using division theorem for polynomials, which says dividend equals divisor into quotient plus remainder. Thus 2x cube plus 4x square plus 7x plus 9, the dividend or px, equals gx into 2x plus 9 minus 5x. Bringing this remainder to our left hand side, we have 2x cubed plus 4x square plus 7x plus 9 minus 9 minus 5x equals gx into 2x, which will bear us 2x cubed plus 4x square plus 7 minus into minus. The product of two negative terms gives us a positive term. Thus plus of 5 into x plus 9 minus 9 equals gx into 2x, which gives us 2x cubed plus 4x square plus 12x equals gx into 2x. We can take 2 as well as x common from these three terms and get 2x into x square plus 2x plus 6 equals gx into 2x. Thus gx equals 2x into x square plus 2x plus 6 over 2x, bringing this 2x from left hand side and changing the left hand side position to right hand side, whereas the right hand side part to left hand side. Cancelling the 2x, we get x square plus 2x plus 6, which is the required divisor. Thank you friends for watching Edupedia word videos.